Okay, so now you've done base 3 halves, so I want you to just stay quiet for just a second. You've also done base 3 halves, but we did about 2 years ago. So
yeah.
Base 3 halves is tricky. What do you think it even means?
Well, it would maybe work the same way. So you have the powers of 3 halves.
Okay, yeah, that's definitely what it's going to do. I'm going to shift all this up, actually. So our powers are going to be 3 halves to the 0, 3 halves to the 1,
9/4,
9/4,
27 eighths,
etc.
Yeah.
What would the next one be?
It would be 81/16.
81/16. Okay. And what about the digits?
You can have 0 or 1.
Yeah, hard to know, right? Because 3 halves is 1.5. It's less than 2.
Yeah.
So that's the tricky thing, and this gets to something we've talked about a little bit in the last month anyway, about really being important to be careful with definitions in math. So there's immediately a kind of a strange problem to try to figure out what you know, to make sure you know what you're talking about when you say base 3 halves. But it turns out, at least, and I don't know if this idea originated with James Tanton or where it came from. I certainly learned it from James Tanton. In binary, we said 2 blocks was equivalent to 1 block shifted over and a 0. What he's going to say is, let's think about it this way: 3 blocks is equivalent to 2 blocks shifted over and a 0. Okay, so let's just see what that would mean. 3 in the 3 halves position would be 3 times 3 halves.
Yep.
Let me move this out of the way. Or what's 3 times 3 halves?
9 halves.
9 halves. And is that the same as 2 in the 9/4? So shifted over 1 and a 0 there?
Yes. Yeah. Because 9/4 times 2 is 9 halves.
Yeah. So here we're actually allowed, in this way of thinking about base 3 halves, we're actually allowed to have 0, 1, and 2. Which is kind of neat.
Yeah.
But let's just start counting. So 1, I'll start 1. Yay! That's 1. So what's 2 going to be?
2 is going to be that. 2.
2. Okay, now I want you to figure out what 3 is going to be. So what do we do?
Well, 3, you can have 2 6 halves, which is 3. And that's going to be a 0.
Okay. And what's happening here? We're adding 1 to this. So what can you show me with the blocks what happens when you add that 1?
Well,
Whoop. Add the 1. So okay, so you add a 1, so we got 3.
Shifts become 2, 0.
Okay, so we always want to add our 1 here and then see what happens. Okay, so what's 4?
4 would be 2, 1.
Alright, what's 5?
2, 2.
Alright, can you show me what 6 is then, please?
Well,
add the 1.
so it would be 1.
Okay.
It shifts over 2, 0.
Okay.
And then this would shift 2, 0. 2, 2, 1, 2,
All right.
2, 0.
What's my rule about shifting here? What's the rule?
Well, a 3 becomes a 2, 0 shifted.
3 becomes a 2, 0.
So you shift
3 becomes a 2 and the 0.
Sorry.
And then 0 plus 1 just stays 1. So this is what 6 is, and we can just even double check. Does this equal 6 when we look at the digits? So I've got
halves.
2 times 9/4, so 9 halves.
Plus 3 halves. And yes, that 12 halves.
So 0. 12 halves is equals 6.
Yep.
Okay. And we can just keep going. And we always want to use that rule that 3 shifts to become a 2, 0.
Yeah, it's
All right.
pretty neat.
All right, so I want you to make a base 3 halves number. Because we're going to have a lot of blocks here, and we'll do it with we'll start with 4 digits and we'll just see what happens.
Okay.
So why don't you make a base 3 halves number about here. Okay. This is going to be 1, 3 halves, 9/4, 27. I see. Make 1.
We could start with 2 here. Oh, no, we would have to start with. Yeah.
Well, you could start with 2 in there.
I guess we could.
You can start with any number you want, 0, 1, or 2.
0, 1, 1.
Okay, awesome.
0, 2.
All right. Can you make a second base 3 halves number above it, please?
2, 0, 1, 0.
Okay. Now, what happens when we add these together?
Well, you're gonna have a 3,
3.
1, 1, 2.
2.
Okay. And what happens to this number now?
So you
3
have
becomes a 2, 0.
2, 0, 1, 1, 2.
Okay. Now, it's a little more tricky to do the arithmetic here, but let's see if we can do it. We had 2. So that's 27/4. 0, 1.
27/8. Here, so that would be 27.
Yeah, 2 times 27/8, 27/4, plus 3 halves.
We have.
So how do I add these two
You
together?
could multiply by 2 over 2.
Okay.
So that would be 6/4.
Uh-huh.
That's 33/4.
So our number on the top is 33/4. And our number on the bottom is 27/8
Plus
Plus 9/4
plus
2. Right? So how do I add those together?
Well, we can multiply by 2 over 2. That would be 18.
All right. What's 18/8? So what's 27 plus 18?
45.
So it's 45/8
Eighth
plus
2. That would be 16/8.
16/8.
So that would be 61/8.
Yeah. So I got 33/4 plus 61/8.
And we can multiply by 2 over 2
Uh-huh.
here.
So I
Would be
get 66 plus 61.
So that's 127.
So we're hoping we get 127/8. So our next digit over here is 81/16.
Yeah.
So this is 81/8, because you have 2 of them.
81/8. Okay.
Plus
Plus
9/4.
All right. How many eighths is that?
That's 18.
18/8.
And then
3 halves
3 halves would be...
is 12/8.
Mm-hmm.
8.
No. It's 27. No.
3 halves is how many eighths?
It's 12 eighths.
Okay.
Yeah.
Plus 2.
2.
Or
Which is
16.
8.
all right. So
81. So 81 plus 18 is 99.
Well, I'd add these together first, but
99/8. Well, these add up to 99/8. So what do these add up to? How many eighths? 12/8 plus 16.
it's 28.
28
So that
eighths.
would be
127/8.
Hey, it worked.
cool.
So, so that worked. So if we now what's different about what we ended up with here too? By the way, when we looked at these random numbers in base 3 halves.
Well,
They're not always an integer.
they're most often not integers, it seems.
Well, well, I don't know. We only looked at one, so it's hard to tell. But we can certainly represent integers, and we can represent non-integers.
Yeah.
Okay, now you want to up for a base 3 halves challenge?
Okay.
All right, let's do a base 3 halves challenge.